Here's another example of how to solve a quadratic equation by completing the square. My first step is to move my existing c to the other side of the equation. So I subtract 6 from each side, and I get x squared plus 5x equals a negative 6. Now I want to find a new c. Remember that equation is c equals b over 2 squared. Or in this case, 5 over 2 squared, or 25 over 4. Be sure to leave it as a fraction. Don't put it into decimal form. And I'm going to add that to both sides of my equation. And on the left-hand side, it may not look like it, but this actually is a perfect square trinomial that I will be able to factor in just a moment. And in order to add the whole number and the fraction, I want to rewrite negative 6 as negative 24 over 4, and add to that my new c, which is 25 over 4. The left-hand side of the equation factors into x plus 5 over 2, quantity squared, and on the right I have 1/4. Next, I'll want to take the square root of each side, and on the right-hand side, I want the positive or negative square root of 1/4. That leaves me with x plus 5/2 equals plus or minus 1/2. The square root of 1 over 4 is the same as the square root of 1 over the square root of 4, or 1/2. This gives me two equations. X plus 5/2 equals a positive 1/2, and x plus 5/2 equals a negative 1/2. And subtracting 5/2 from each side, I have x equals negative 4 over 2, or x equals a negative 2, and x equals a negative 6 over 2, or x equals a negative 3. And that's how to solve a quadratic equation by completing the square when b is an odd number.